Hi there, folks. Today we're looking at matrices and matrix operations, and we're only looking at the very basic types of things here. So just kind of get an understanding of what a matrix is and what operations look like when we're dealing with matrices. We'll deal with just addition, subtraction, and multiplying by scale factors here. Okay, and so when we're talking about a matrix is just a rectangular arrangement of numbers. All right, we use these brackets and we put things in rows and columns. And we can use this for organizing data. One of the big things we use it for in algebra or algebra 2 is organizing systems of equations. Okay. The plural of the word matrix is matrices. That's just how we say it when we're talking about multiple of these things. And so when we name these things, we always name it in terms of the number of rows and the number of columns. And so like for this one, I look at this like these would be the columns. Remember, the columns are the things that go up and down. And then these would be the rows. Those things go left and right. Okay. And so this one, we would call this a 3 by 2 matrix. And it's a 3 by 2 matrix because it's got three rows and 2 columns. Okay. So we would say matrix A is a 3 by 2 matrix. Okay, so just when we talk about these things, and when you're trying to plug these things into graphing calculator and stuff like that, you need to tell it what size matrix it is. And so you have to tell it a 3 by 2 if you want a matrix that has these particular dimensions. Okay. And so when we're looking at these things, the numbers that we see inside of the matrix, we just call those elements. So the matrix above this one has 6 elements in it. The 5, the 2, the other 2, the 0, the 3, and the next 2. The next 0. Okay, so those are all elements of the matrix. So when we talk about the elements, we're just talking about those individual values that have been arranged. Okay. Adding and subtracting matrices, we can only add and subtract matrices that have the same dimensions. Okay, so if they're equal in terms of their size, in terms of rows and columns, we're allowed to add these things. If we have 2 matrices that are the same and we want to add or subtract them, we simply add or subtract the corresponding elements. Okay, and so like the element that's in the top left gets added to the element that's in the top left, and the element that's at the bottom right gets added to the element that's at the bottom right. Okay, so everything's based on position. And so we just add the values that are in the same position. We subtract the values that are in the same position. For example, when I look at something like this guy, I'm allowed to add these matrices because they're the same size. It's a 2 by 2 matrix plus another 2 by 2 matrix. And when I add those together, it should give me then a 2 by 2 matrix. So I'll end up with another 2 by 2 matrix. And I just add things that are in the same spot. So like when I look at this one, this guy and this guy are in the same spot. So I add them together and that gives me a -8. And the 2 and the -6 here are in the same spot. So I add them together and that gives me, I don't know why I wrote a plus sign there. That gives me a -4. And then the next position here, the 7 and the -4, that adds up to a 3. The -3 and the 2, that adds up to a -1. And so when I add the 2 by 2 matrices, I get a new 2 by 2 matrix that represents the addition of each of those elements. Okay, that's it. Like that's how we add or subtract matrices. If I look at the next one, when we do this next one, there's 2 ways we can kind of approach this. We can either literally think about subtracting the pieces, or if you want, you could distribute this negative. We could change this to adding the opposite and change all of these to this. And then we'd be adding them together. And that's very similar to what we do when we're adding and subtracting normally. Or we can just look at these and say, hey, let's just subtract the things that are in the same position. Again, these matrices are the same size, and so when I add these together, I'm going to get another 3 by 2 matrix. And so I add things that are in the same position, or subtract things in the same position this time. So 2 minus a -1, that's a +3. Okay, and then the next one's 11 minus the 8 is also a 3. Here, the -2 minus the -6, that's a +4. And if you're worried about making sign errors, then you should absolutely change this subtraction to adding the opposite. Makes it a little bit easier. 3 minus the 4 is a -1. I'm just going to roll with it the way it is. 1 minus 0. And I missed taking off that plus sign there. There we go. And now -5 minus the -3 is like -5 plus 3, which is a -2. Okay. Again, if you're worried about making sign errors on something like this guy, it's pretty easy to change this to adding the opposite, just like we've always done with subtraction. Okay. A scalar, when you talk about a scalar is just a real number factor. Typically, it's just something we're multiplying by. So when we talk about scalar multiplication for a matrix, we're simply just multiplying the matrix by a real number, okay, a real number factor. And the reason it's factored is because it's listed on the outside as a multiple. Okay, and so scalar multiplication, I simply multiply each element by whatever the scalar happens to be. Okay, and so in this first example here, I've got a scalar of 3. So when I do scalar multiplication, I simply distribute that 3 to the entire matrix. So every element inside this thing gets multiplied by that 3. And so here I'm still going to get a a 2 by 2 matrix, but I multiply all 4 of these elements. I do 3 times the 4 is a 12. I do 3 times the -1 is a -3. 3 times the 2 is a 6. And 3 times the -7 is a -21. Okay. And so again, that's how multiplication by a scalar multiplication works with matrices. We simply just multiply each element. All right. Likewise here, I'm going to multiply that -4 by each of the elements. And so for this particular example, I'm going to get a positive 44 for that first one. -4 times the 12 is a -48. -4 times the 6 is -24. Negative 20 here, -40 here, and a 0 for this last one. And again, I end with the same dimensions I started with. That's kind of a common theme throughout mathematics. If you have to have the same thing in order to do something, it stays the same throughout the process. And here, the size doesn't change as I'm multiplying the size and dimensions of the matrix. We just multiply each value. Okay. And then kind of stringing that together, we still have to follow order of operations just like we do any other time. So in this particular example, I would have to do the multiplication first. And so I'm going to do that scalar multiplication and multiply that second matrix by 6. You could also multiply by -6 if we wanted to do it that way. If I were to multiply by -6, let me just copy this first matrix down. Okay, instead of multiplying by 6 and then subtracting, I can multiply by -6. And if I multiply by -6, all of a sudden I'm going to get a plus sign in here. And now I multiply each of these by -6. That's a 0, a -18, a +6, and a -6. Okay, and because I distributed it as a -6, now I'm adding these two matrices. If I had distributed and multiplied by just the +6, now I'd be subtracting these matrices. And now I can kind of finish this guy off. And so when I add these, I just add the elements that are in corresponding positions. So here I've got a 1, a -20, a 7, and a -4. Okay, that's it. Last thing we're going to do here is just kind of comparing matrices. When you look at something like this guy, if I'm saying that the left side, I've set this up like an equation, the left side is equal to the right side, just means that the corresponding elements should be equivalent. Okay, and so there's a couple ways to approach this. We could go right to just looking at this and saying, hey, this 2x plus the 3 should be equal to the 15. We can kind of think of that like an equation. If it's easier and we want to, we can combine this into one matrix first to make it just a little bit easier on the eyes as we move forward and say, okay, this is going to be a 2x plus 3 for that first section. Here, this is going to be a 3y minus 2. This guy is going to be an x plus y plus z. The only thing that gets a little bit uneasy here is it's maybe tough to see that like these are still broken down into 4 elements. Even though the 2x plus 3 looks like multiple things, it's all counted as that first element. Okay. And now if I wanted to kind of set these up as equations, I would look at that first one and say, oh, well, now based on the positions, the 2x plus 3 is equal to the 15. Okay. Based on the second position here, that's a 3y minus 2 is equal to the 19. Okay. And based on this position, that's x. My pen just seemed to die for a second. There we go. X plus y plus z equals the 10. And then that last position, z equals the -3. Okay. And so for this one, if I wanted to solve essentially this system of equations, I just have to use substitution or elimination. For this one, really substitution makes the most sense. I already have the z value down here. Up here, I can easily solve for x by subtracting the 3 from each side. That gives me a 2x equals 12. And then I'm going to divide each side by the 2. So I have my x value here of x equals 6. Over here, I can solve this for y. Really, I don't even need that last one. Although the last one will be a nice one to help me check. 3y equals 21, and then divide each side by the 3. So I end up with y equals 7. And again, I already have down here, I've got all 3 of these pieces. I already had z equals -3. That last equation I didn't really need, but it acts really nicely as a check for these guys. It should say 6 plus y, which was 7, plus the -3, should give me a 10, and it certainly does. And so that's a nice check for me. Even though I didn't need that one to help me solve this system, it's still nice to have it there so I can check. And of course, because this is x, y, z, I could write this answer as an ordered triple: 6, 7, -3. Okay, so just that idea of using matrices, understanding the dimensions of matrices, understanding those corresponding positions so that I can add, so that I can multiply, so that I can subtract, and so that I can even compare matrices in the format of an equation. Okay.